Good evening, Mamrita. So let us try to discuss the concept what we have discussed yesterday. Let us revise the things what we have done yesterday. Let's go back to the concept called geometry here. As I told you, geometry basic things like point, line, a line segment. We also discussed about ray, and we have understood about what is an angle and different types of angle. As we told about point here, line, and you know the difference between a line and line segment. A line segment will have what you call two end points, whereas a line will have extended to an infinite distance in the both ends. And when you talk about a ray, as I told you, it is one such fixed point, and other it will have an infinite distance to be covered. So example, as I told you, if we take A to B, here AB is a ray, there A is a fixed point and B is an infinite point where it may end at any point. A line segment is two end points will have a fixed ends, so that it will be measured easily. And then coming to line segments, as I told you, AB line segment may be taken where the points may be get extended on both sides, and a line segment may be taken one point to be fixed, another point may be get extended, and a line segment where both ends are going to be get fixed. And then coming to angle, as we told, angle is a measure, I can say the distance that is being covered as an angular distance, that we call it as an angle. So an angle is going to be calculated whenever two lines are meeting at one point, so that there will be a measurement taken in theta. So here B is a vertex. If you take AB and BC, B is a vertex where at B we are going to measure the angle. So angle ABC we are going to measure, or it is also measured as mentioned as angle B. So AB and BC are two arms. Like measuring of an angle, so generally angle is measured with the degrees. So the next element is, it is about minutes, and then below that we're going to have seconds. So you can measure like this: 60 degrees, you can say 1 degree is 60 minutes, and 1 minute is 60 seconds. So likewise we're going to measure here, as it is an angular distance. Generally angle is taken for measuring the angular distance, and we're going to have the shortest form called seconds, minutes, and then it is a degree. Now coming to types of angles, as we told, acute angle, right angle, obtuse angle, straight angle, and reflex angle. So based on the angle value, we're going to have this, and with the help of these angles only we're going to have different kinds of triangles. Same as acute angle, whenever one of the angle of a triangle is acute, then we call it as acute angle triangle. When one of the angle of a triangle is right angle, then it is called as a right angle triangle. As usual, when one of the angle is obtuse, then it is going to be obtuse angle triangle. And straight angle is the point on any point on a straight line, is going to be making this straight angle, it is 180 degrees. And reflex angle is whenever the angle is more than 180 and less than 360, it is called as a reflex angle. So obviously we're going to have clockwise measurement, so we know that clockwise measurement we're going to take it. And then coming to the next point, that is we have discussed about angles here. Whenever I talk about at any point in a plane, we're going to have 360 degrees all around the clock. And then I told you about adjacent angles. Two angles are said to be adjacent when they have a common vertex. First thing, at the same time they must have a common arm. So here in this example, angle AOB and angle BOC. So there are two angles here. OB is a common arm, where angle AOB is adjacent to angle BOC. We call it as adjacent angles because O is a common vertex and here OB is a common arm. So in such case these two are called as adjacent angles. So when we call them, when we want to call it as an adjacent angles, they must have to possess these properties. First of all, they must have a common vertex and they have a common arm, and the other arms of two angles lie in opposite direction. Let us say here angle AOB, where OA arm is exactly opposite direction to OC arm. That's why angle AOB and angle BOC are adjacent angles. Then coming to the opposite vertex angles, I told you yesterday regarding this. When you take two lines cutting each other or intersecting at each other, so there will be chance of possibility of four angles here. So you see AB and CD are two lines So AB and CD are intersecting at one point called O. So O is a point where AB and CD are getting intersecting, and I can say AOC, angle AOC. Here angle AOC, you'll have opposite vertex angle like angle BOD. Exactly, angle AOC will be equals to angle BOD. You can see the measurement. It may be any value, but they have to be equal. Then angle AOD is equals to angle BOC. Reason is again opposite vertex angle. So that's what we can say. These opposite vertex angles are always going to be equal. Then I told about this thing like vertically opposite angles are always equal. That's what we have mentioned here. And when you take about measurement of complete angle here, you see in this diagram angle XOY. So here XOY, it is A degree within, so called as within angle, and reflective angle is B degrees. So the sum of these A and B should be equals to 360 degrees. Now let us move to the complementary and supplementary angles. As I told you about, whenever two angles are called as complementary, that means the sum of those two angles should be equals to 90 degrees. So if I say what is the complementary angle for 20, so 20 plus 70 is equals to 90 degrees. So 70 is going to be the complementary angle. So complementary means whatever the value, that angle whatever that we have given, so you should add some value to that. The value which are that you add here as angle, that is going to lead to 90 degrees. In case if it is 90, then each other mutually we can say one angle is complementary to the other angle. Here 20 degrees is complementary to 70 degrees, 70 is complementary to 20 degrees. Now moving to the next property, that is supplementary angles. So when you say about the sum of the two angles is 180, so in the previous case it was 90 degrees, now it is 180 degrees. Whenever the two angles are added, let us say when you take sum of the two angles are equals to 180, then we call them mutually supplementary. So here if I take any value, let us say 40 degrees, what is the supplementary angle of 40 degrees? Then 40 plus 140 is equals to 180. So therefore 140 will be called as supplementary angle for 40 degrees. Now moving to the next property, so called as transversal. So even this point we have discussed yesterday, but let us understand here. So here transversal is nothing but when you take two lines, AB and CD are two straight lines, so there is a one line so called as a transverse, we call it as transverse. PQ cuts the straight line AB and CD, so it is called as a transversal. So here PQ is called as a transversal. You can see there are four angles formed at on line A at one point here, and where PQ is intersecting AB, at that point we can say 1378. We are just taking numbers here to measure the angles. 1378 are four angles formed on A because of PQ transversal, and because of PQ transversal on CD we got 2, 4, 6, 5, 6. So let us understand about this. So when you have these 8 angles here for 2 points, so there are something called interior angles and exterior angles. We have to understand these points, very important. Let us say here when you talk about interior angles, here 1, 3, 2, 4 are called as 1, 3, 2, 4 are called as interior angles. They are called as interior because they are being inside of that transversal. And 5, 6, 7, 8 are called as exterior angles. That means they are opened up. Okay, that is why we call them as exterior angles. Now two pairs of interior alternative angles. You take angles here marked 1 and 2 from one pair, 1 and 2 from one pair. You see angle 1 and angle 2. Angle 1 and angle 2, they are interior alternate angles. Interior alternate angles. Since here PQ is transversal, so if you take these two 1, 3, 2, 4 here, 1 and 2 are called as interior alternative angles. 1 and 2 are called as interior alternative angles. At the same time 3 and 4 are called as interior alternative angles. So here two pairs we got. So when you take 1, 2, 3, 4 here are interior angles, then 1 and 2 are one set of interior alternative angles, and 3 and 4 are one set of interior alternative angles. Okay, so now let us go for exterior alternative angles. So there are 4 exterior alternative angles. Here 5, 6, 7, 8 they have given. So here also 7 and 6 or 6 and 7 you can say. 6 and 7 are exterior alternative angles. They are called as exterior alternative angles. And here 5 and 8. Now 5 and 8 are called as exterior alternative angles. So we'll have two set of interior alternative angles and two set of exterior alternative angles. Next, four pairs of corresponding angles. You can see here what are the corresponding angles. See here mark 3 and 6. Now see here exactly, however 3 is there, the 3 will be same as 6 here. So 3 and 6 are one corresponding angle, that is one corresponding set of one corresponding angle. For 1 and 5 again we are going to have corresponding angles. So wherever 1 is there, in the same position 5 exists in the other line. So that's why 3 and 6, 1 and 5, and 8 and 2, 7 and 4. So that's why there are four pairs of corresponding angles. Now let us just revise. There are 4 interior angles and 4 exterior angles, and when you talk about alternative angles within interior, so 2 pairs of interior alternative angles and 2 pairs of exterior alternative angles and 4 pairs of corresponding angles. 4 pairs of corresponding angles. Now 2 pairs of allied or co-interior or conjuncted angles. Let us understand this. If you take 3 and 2, for example, 3 and 2 are called as co-interior. We call it as co-interior or conjoined angles. We can say that. So here you see 3 2 are conjoined. 3 2 are conjoined here. Okay. Then at the same time, one more is, you can see one more here. It is about yes, it is about 4 pairs of just let us go back here. 2 pairs of allied co-interior or conjoined angles here. 3 and 2 from one pair, and angles marked 1 and 4. You can see 1 and 4 are also called as conjoined angles. Okay, now let us move to the next concept called parallel lines. I hope you understood this transversal. Generally we have to understand about interior alternative, interior alternative, exterior alternative, corresponding angles. Now moving to parallel lines. Parallel line means, generally the property of parallel lines means those lines which may not intersect at any point. Even if you extend it to infinite distance also, they won't intersect at any point. Such lines are called as parallel lines. Now if you see AB and CD are two lines and they are parallel lines. They are called as parallel lines because they'll maintain the equidistance. So whatever the distance that is there between AB and CD will be constant if you extend it to infinite distance also. Such lines are called as parallel lines. And when you take PQ, a transversal, so here two straight lines are said to be parallel only when they will not meet anywhere, and no matter how long they are going to be produced in daily direction. I told you infinite distance. And here the adjacent figure here, when you take AB and CD, that AB and CD are two parallel lines and PQ is any transversal cutting these two lines at two different points, where creating, actually it is generating 4 angles. The 4 angles are formed because of each intersection point. Now if you take interior and exterior alternative angles here, you take for example 3 and 6, angle 3 and angle 6. You can take example here, angle 3 and angle 6 are example for what? Interior alternative angles. Very simple. So other side of it. Next, 4 and 5, here both are interior angles and they are alternative angles. So 4 and 5, angle 4 and angle 5 are interior alternative angles. I hope you understood this here. Interior alternative angles are equal. Interior alternative angles are always equal. Now then when you take, so it is possible only with the parallel lines. Okay, not about the other lines. So previous example we just understood about what are interior and what are exterior angles. Now here we are trying to understand the relationship. So when you take AB and CD, two parallel lines, as we have told, there is 4 interior angles. So alternative interior angles we are taking here. Angle 3 and angle 6 are one set of interior alternative angles. Angle 4 and angle 5 are other set of interior alternative angles. In the same way, when you take exterior angles, there are 4 exterior angles in this particular particular construction. 1, 2, 7, 8 are exterior angles. Now in the same way, angle 1 is equals to angle 8. Angle 1 is equals to angle 8 because exterior alternative angles are equal. Exterior alternative angles are equal. Then angle 2 and angle 7 are exterior alternative angles. Angle 2 and angle 7 are exterior alternative angles. Okay, now when we take these two, for example, corresponding angles are equal, I told, and here the corresponding angles also you can take. For example, for angle 1 the corresponding angle is angle 5, angle 2 the corresponding angle is angle 6, the same position where it is lying in the other point. Angle 3 is equals to angle 7, angle 4 is equals to angle 8. Okay, likewise you can take this parallel lines. Okay, whenever there is a transversal, we'll have these properties. We should remember that interior alternative angles are equal as well as exterior alternative angles are equal, and corresponding angles are also equal. So corresponding angles are also going to be equal, and co-interior, as I told, allied angles are supplementary. You see, angle 3 plus angle 5, so they are called as co-interior. Okay, they are called as co-interior angles. So the sum of them is angle 3 plus angle 5 and angle 4 plus angle 6. It is possible only in case of interiors, not exteriors. But angle 1, you cannot say angle 1 plus angle 7 is 8, because it is only in case of interior, allied angles. So angle 3 plus angle 5 is 8, 180, and angle 4 plus angle 6 is also 180. So three properties we took here. First is about interior alternative angles are equal, external alternative angles are equal, and corresponding angles are equal. And one more very important thing is, when we take co-interior angles are always going to be supplementary. Supplementary means sum of them is 180 degrees. Then conditions of parallelism. So generally you can say that a pair of alternate angles are equal, or a pair of corresponding angles are equal. When we say these properties, three properties, one pair of alternative angles are equal, or a pair of corresponding angles are equal, or it may be sum of the interior angles on the same side is 180, or on transversal is 180, or supplementary, then those two straight lines are called as parallel lines, or they are parallel to each other. So these are the properties. Please remember the concept here. Right.